Figure 7.14, passing arrays and individual array elements to functions. In the previous lesson, we started talking a little bit about pass by value versus pass by reference, and we're going to kind of revisit that discussion a little bit here with an example that shows you what happens when you pass an entire array to a function versus what happens when you pass individual elements of an array to a function. So first I'm going to just run this program so that we have the output on the screen and can refer to it as we look through the source code. And now we'll take a look at the source code and I'll bounce back and forth with that output. So in this example, we have two different functions we're going to be studying. One called modify array, which receives as its argument an integer array. Notice the use of the square brackets in the parameter type. If you have square brackets like that, it indicates that you have a one-dimensional, a single-dimensional array of integers. And again, we'll talk in a later lesson, later video of this lesson rather, about multi-dimensional arrays as well. Now, when you pass arrays to functions in C++, the arrays don't know their own size. So typically, a function that receives an array will also receive a second parameter at least, which specifies the number of elements, the size of that array. Separately, we're going to have a function called modify element, which will receive a single integer element from an array and attempt to modify that element. And what we're going to see here is when you pass an array into a function, its elements can be modified by that function. When you pass an individual element, you're just getting a copy of that element, so the original element's value remains the same in memory. Now, for the first time in this program, we're declaring an integer as a const integer called array size with the value 5 as its initial value. When you create a constant, it must be initialized where it's declared, and the array size is being used here to specify the number of elements in our array. And basically what this does is it gives a name to the size of the array, which makes the code a little bit more readable. And if you have many different arrays, you can name these constants differently as you need to. And then separately, because it is a constant, it is not modifiable. So basically, the name array size represents the value 5 from this point forward in the program. And the last thing I need to mention is that whatever you use to specify the number of elements in the array has to be a constant in C++. It cannot be a non-constant variable. It cannot be a function that returns a value. It must be either a variable that is declared to be constant or an explicit value. As well as another option, which is what we did in our earlier examples. So in this case, we have an integer array with 5 elements, and those elements are initialized with the values from 0 through 4. And now what we want to do is show you the effects of passing an entire array to a function. So the first thing we do is show you the values in the original array. And notice that we're now using our constant as the part of the condition for looping through the array. And now if we want to change this example to have an array size of 10, we can change it once here, and then every place where we use array size in the program will automatically have that new value. So we're going to loop through the elements of the array and display their values. Then we're going to pass the array to the modify array function, giving it the array name A and the number of elements in the array. And then when we get back, we're going to redisplay the contents of the array. Now, let's take a look at the modify array function, which is receiving this array called A and its size. So here's modify array. And when you're receiving an array as a parameter, you need to specify square brackets to indicate that it is an array that you expect to receive. Notice that we don't specify the size of the array. This is the case for one-dimensional arrays. Technically, this function can receive a one-dimensional array of any length. And of course, we're receiving as the second argument the number of elements. So our loop here is capable of receiving any one-dimensional integer array of any size. And if we pass in the appropriate size, this loop will walk one element at a time through the array and multiply each element of the array by 2, storing the result back into that element. Now, in reality, what we're really receiving here is not the array A. We're receiving the array A's location in memory. And if you think about it, this makes a lot of sense, because let's assume that array has 10 billion elements in it. If we had to make a copy of 10 billion elements, we might actually wind up running out of memory in our system. And it might be, if we have that much memory, we may simply slow down the program to a point where it's not even really functional. So rather than passing in a copy of a massive entity, we pass in its location in memory, and then we just interact with that location directly. So arrays are actually pointers, and we're going to talk more about that in the next lesson. But the key thing here is to know that when you receive an array as an argument, you can modify the array's elements. Now, this may look like we're just modifying a local array called B, but when you look at the output, you can see that when we first displayed the values of the original array, there were 0 through 4, and then after we called modify array, the element values are now 0, 2, 4, 6, 8, because we multiplied every element by 2, and of course 2 times 0 is still 0. So when you pass an array to a function, by default the function is allowed to change the values in that array. Now, we also, going back up to main here, want to show you what happens when you pass an individual element to a function. So here we're going to pass an array element by value, and we show you the value of a sub 3 before we call modify element. And just going back, I guess I closed that window by accident, so let me rerun the program here. So you can see a sub 3 initially is 6, a sub 0, a sub 1, a sub 2, a sub 3 is 6. And we're going to pass it into our modify element function. Here a sub 3 is passed to the function. Modify element is going to receive that integer, and notice there's no ampersand here, so it's receiving it by value, making a copy. We try to modify the local parameter e by multiplying it by 2 and storing the value in e. And when we output that value, we can see that its value is 12 inside the function. But when we come back to main and we display that value again here, we can see that the original value 6 that was passed in still exists in main. So when you pass the name of an array to a function, you are giving the function direct access to that array in memory. When you pass an individual array element to a function and there's no reference parameter, you are passing a copy of that element to the function. So you may ask, well, if you're going to always be passing the location of an array into a function, and then that function has direct access to the array in memory, how do you prevent the function from modifying the array? And the answer is with the const keyword. If I say const here at line 45, what I'm saying is that my function is going to receive an array of integer constants. And now you can see here I'm getting a squiggly indicating an error message. It says expression must be a modifiable L value, meaning it must be something that I can assign a value to. When I apply const to the parameter, what that does is it prevents me inside the body of this function from modifying the contents of the array. And if I try to compile this, you'll see that I get an error message. You cannot assign to a variable that is const. And so it's actually telling me now that it considers the array element to be const, and I'm actually trying to assign the result of multiplying that value by 2 and storing the result back into that element of the array, which I am not allowed to do if the function thinks the array is a constant integer array, an array of integer constant values. So it's very common when you're dealing with arrays and you're passing them to functions for the function to receive the array with the const keyword applied to its parameter, which is an indication that the function will use the values in the array but not modify those values.